Hello and welcome. Today we're going to be talking about stairlifts and how our products can help you within the industry. Hi, my name is Zach McKay and I'm the Key Accounts Manager here at Motion Control Products, and today we are joined by Jonathan Gulliver, who is an expert within the stairlift industry.
Hi Zach, it's good to be back at Motion Control again.
Good, so questions. Stairlifts, pretty simple type of product, aren't they?
Well Zach, basically there's two fundamental types of stairlifts. Straight stairlifts, you're right, they're really quite simple.
Yeah.
Curved stairlifts, they can get very complicated.
And tell us exactly how simple straight stairlifts are.
Okay, the only thing with a straight stairlift really is how long do you want it? A straight stairlift works with a rack and pinion drive up the length of the stairlift. It has a worm wheel motor gearbox with typically a brushed motor, and it stops and slows down simply with limit switches. So yeah, they're really quite simple.
Okay, and curved stairlifts, you said they're a little bit more complex.
Curved stairlifts can be a lot more complex, individually designed with loads of bends, and the rail will vary in angle, sometimes throughout the whole length of the stairlift rail. Modern single rail stairlifts, the chair and the carriage need to stay upright even though the angle of the rail is varying. There'll be an electronic map of the whole stairlift rail, which is governed by encoder feedback from the main motor gearbox, which tells the carriage where it is on the rail. The map tells the carriage then what angle to be at any point on the rail, and a secondary motor gearbox will be driven by that map to be at the correct angle through a drive mechanism. So there's going to be optical encoder feedback from the main motor gearbox and also from that secondary motor gearbox. The map will also control the speed of the product to make sure it stays at less than 0.15 meters per second. And sometimes we're seeing these days brushless DC motors driving some of those gearboxes.
And efficiencies, they're pretty important, I can imagine.
Absolutely, Zach. Efficiency is important for three reasons. So, first reason, very steep rails. You know those tall, thin houses in Amsterdam? They're the classic ones for the steepest possible rails in the stairlift world. Those rails can go up to 70 degrees. And when a rail is that steep, you need a lot of power to get up the rail. Higher efficiency will help with keeping that power under control. Second reason, really long stairlift rails. So again, another really good example would be in Italy and sometimes in Sweden and other places. You'll see big old apartment blocks where there isn't space for a vertical lift. In those big old apartment blocks, they'll have really long stairlift rails, and they can be 20, even 40 meters long. The stairlift is driven by a battery or a pair of batteries inside the carriage, and in order to get the most out of them for a long stairlift rail, it's good for it to be efficient. The third reason for having high efficiency is for the larger users.
Okay, cool. So from our point of view here at MCP, straight stairlifts, pretty simple. All they really need is a brushed DC motor with a worm and wheel gearbox delivering a good amount of torque, push the user up and down the stairlift. So like I say, it is pretty straightforward. These can also be used on curved stairlifts. However, we are getting a lot more inquiries for this type of application for moving over from DC brush to BLDC. There's a few reasons, obviously. Mainly, there's no brushes, which means that there's no brush wear, generally giving the motor a lot more of a longer life. Like John's mentioned, efficiencies are really important, so they're super efficient, BLDC. They stay much more cooler than brush motors, and they can deliver a good amount of torque in a far smaller size. They can be coupled up with optical encoders tend to be used for this type of industry because they're readily available, extremely cost effective, and very reliable too. So yeah, that's generally why BLDC is being seen and a lot more in this type of industry. But John, compact axes within a stairlift, can you tell us a bit more about that?
Well, we're seeing more and more demand for additional smaller motor gearboxes for powering parts of the stairlift to make it more comfortable and easier for the users. A classic example is the powered swivel. So that at the top of the stairlift, the whole chair will swivel round so that it's much easier for the user to get on and off. They're no longer hanging over the staircase. And sometimes you can even have a powered swivel at the bottom or at both ends, which gives you a complicated mechanism. Another one is powered footrests, where it makes it easier for the user to get their feet on and off without having to operate the footrest manually. You put in a powered footrest. Now these applications, they don't need the power and the torque of the main motor gearboxes, but they do require very small and compact sizes, simply because it's very important for the stairlift to be small and convenient for the user so that it's comfortable for them to get on and off.
So as John's mentioned, size does matter in this type of application. In this axis, MCP were set with the task of supplying a compact geared motor, so super compact gearbox, DC brush motor within a good tight space, but still delivering a good amount of torque on the footrest axis and the swivel axis. This is what we delivered, and the customer was extremely happy. So yeah, thank you for listening to us today. And if you would like to find a bit more about our product and our range, please contact us in the contact us below. And also, please subscribe on our YouTube channels if you'd like to hear a bit more about the videos that we release in the future. Thank you.